Hi, this is a video to show off the Foliage Renderer. I'm going to be using Nature Manufacturer's Meadow Environments as an example to show this off so that I can show how you would convert shaders and other things to the system. So this is a pretty nice collection of assets and a little environment to work with. So the first thing I'm going to do is convert this over to Foliage Renderer. And when that happens, we might see things freak out a little bit because the shaders are not compatible. So let's just do that now. We create the foliage renderer, and you'll see that everything freaks out. And that is because the renderer needs special shaders on them, and not all the shaders that you find will come automatically converted to foliage renderer. Some do. But in this case, they are not because this is an older asset. So what we're going to do is when we did that create, it created this foliage renderer and indirect renderer. We'll get into what these do later, but we're going to select the foliage renderer and we're just going to hit the scan button. And this will scan for the shaders that are currently in use. If I make this a little bigger so you can see the full path, you can see the full paths of the shaders here. And we can just click fix on these, and that will patch these shaders to work with the foliage renderer. And so now we see everything is rendering correctly again, and all of our shaders have been patched to be versions that work, particularly with the foliage renderer. Now what it'll actually do is it'll create another version of this shader with an _FR extension and convert all the assets materials to point to that shader instead. This is a destructive operation in terms of your materials because it is changing which shader they use. But it does not replace the original shader, so it's you can swap them back. So we're now rendering with Foliage Renderer, and this is an indirect renderer. So one of the big points of this is to be able to draw vegetation out a lot further. So on the settings here for trees and details, we by default use the quality settings, but I can override that and just go ahead and set a really far detail distance here. But you'll notice that the details aren't really drawing out any further than they were before. And that's because this shader happens to have a distance fade on it where it scales down the objects. So not every shader is going to have this. But if your shader, the rendering system for terrain details in Unity doesn't do anything to hide transitions. It doesn't fade out objects. It doesn't shrink them or any of those types of things. So if a lot of times the good vegetation shaders will add these features in. And that means that because the detail system doesn't inform them about anything, you have to often set up the materials to do the right thing. So to do that, we're going to go into this block of materials here for the grass. And down here on these shaders is this call far start and end distance. And this is basically the distance at which it's going to start shrinking these. And so we can adjust this to something that fits with the distance we want to draw them at. But for now, I'm just going to crank them all up so that everything draws really far so we can see what's going on. So, and unfortunately I have to do these one at a time because they are different materials in some cases. But it seems like mostly we're just using that last material. Got some other little ones coming in there. Yep. And now basically our shaders are set up so they're not fading really, really early, and we can draw vegetation quite far into the distance, which is a lot nicer. So if you were to try this with Unity Terrain, this would turn into a lot of draw calls. So to understand why, there are two types of instancing that you can have in Unity. One is called just instancing. There's actually more types than two. But for the purpose of talking about terrain details, there's two. There's a generic instancing method which will draw up to 1,023 instances as one draw call. And then there is indirect instancing, which has no limit. So Unity Terrain by default uses the type that limits it 1,023 instances, and that's actually hardware dependent. So for instance, on my machine, most of the time it'll only do 512. And that means you need to submit one draw call to the GPU for every 512 objects that you're drawing with your details. So obviously that, when you have far view distances like this, is going to greatly limit what you can draw. because your CPU is going to spend a lot of time submitting draw calls, and everything's going to be a lot heavier. But if you do that through indirect rendering, indirect instancing, which is what Foliage Render uses, then you can draw many more objects in a single draw call, because there is no more limit. There's a lot more details to those differences, but for the sake of this video, that's enough to talk about for now. So now we see we can really push this detailed distances out quite a lot, and we still have very acceptable performance, and a much better looking scene. And we also don't need to worry too much about all those tricks of like how do we cover up the fade between the grass and when it goes out, which were really important when you had a much shorter detail distance. So you might still want to do all those things and adjust these parameters to get a nice smooth fade out on the edge, because you'll still see the edge. Like if I back up enough, you still see the edge over there. So using whatever techniques you want to kind of make that a little smoother is a win, but just drawing the details out a lot further is a really nice thing. So now that I've showed you how to convert a scene, I'm going to go over into my own testing scenes and show you a little bit about how this thing works. And let's just start with the example here. There are two example scenes in the package. One is to sort of a more traditional scene, and another is to show off features of the renderer that you can toggle on and off and see what they do. This also has some nice tricks that the Foliage Renderer can do, shown off here as well. As an example, you can see these rocks. So this is obviously a lot of instances, but it's actually not as many as you think, because I'm not drawing individual rocks, I'm drawing collections of rocks, and what it's actually doing is conforming that collection so that it follows the terrain instead of being flat. So if I were to go to the Foliage Renderer and disable it for a second, what you'll see is what the Unity terrain would draw, and you'll see that these rocks are now floating because they're not being conformed to the terrain. They're not even being aligned to the terrain. They're just a big clump of flat rocks. So this ability to conform your model to the terrain, to its actual surface representation, lets you use much bigger instancing objects. You can use photo scans and interesting content that would be otherwise hard to use on the terrain. And so this can be a nice replacement for tessellation in some ways, in which you can scatter your terrain with objects, have it conform to that terrain, and create a really nice surface. And this is actually very, very cheap with the Foliage Renderer because of the way it operates and draws. So there's essentially three components to this when you set it up on a terrain. There's the Foliage Renderer component itself. There's the indirect renderer, which is the raw rendering system. And then on each terrain, you'll have a component on here, which if I, right there, and that you don't have to think about too much, but one little debug thing that's on here is you can see that it's actually set up to render the albedo map of the terrain, which along with that height information and also the normal information, it is passing to the shaders being used on the terrain. And so that lets you do things like tint. These rocks are tinted towards the color of the terrain, for instance. I probably wouldn't do this with these rocks, but it is a showing off the feature of how you could tint the rocks to better match the terrain texture using that albedo texture, and also conform these things to the terrain themselves. So all that information is available to the shaders to do interesting things with, and it works across multiple terrains and all of that kind of good stuff. So let's talk about the core rendering system itself. This is the indirect renderer object, and this has basic options for the rendering system on it. Whether you want to do frustum culling for the shadows, what the sun is in your scene, and options for high Z occlusion culling. It also has some options for handling the caches of graphics buffers, and so this max graphics buffer caches. When this is higher, it's going to use more memory, but it will new up new buffers less often. When it's lower, it will tend to create new buffers more often to resize them effectively. So in terms of this next section, this is basically the output of how much memory we're using. Right now we're using 13 megabytes for the whole system. And you can see how much used memory is there and how much is reserved by that graphics buffer system, and what's being taken up by various things. And when it has to resize a buffer and has to new one up, it will increment this resize events. So this can take a little time to resize those buffers. So it's just a little bit of a trade-off, basically, that you can adjust this number. If you're on PCs with lots of memory, then you might want this higher and just kind of take a little time off the frame time. And then you see some basic rendering stats. So right now it's doing 22 draw calls for everything. That's all the trees, all these grass sections, etc. And then you can see some culling data. So in this particular view right now, it's 64,000 instances that we're attempting to render. And then what you can do is hit this capture button and it will show you how many it actually needed to render. And so after it did culling, and that's both on the shadows and on the visible objects, it ends up with only needing to draw 2,426 visible objects and 4,128 shadows. Shadows can extend into the view, so we often have to draw more of them than we do the regular stuff. So to show some of this off, I'm going to flip over to this debugging scene right now, which is, let's see here, I might have to go into the actual thing here. So in the package here, let me go to Foliage Renderer, there it is. In the examples, there are two files. There's the train example, which we're looking at now, and then this occlusion test. And what this will do is allow you to see what's actually happening with Foliage Renderer's occlusion. So if we come up here, now there's a little trick here, which is that you either have to have the game view active or swap over to it and back to get it to register, because what it's actually doing is we're looking at the scene, but we're seeing the results of this view here. So if I put this on the screen at the same time, there we go. And let's just make this a little wider. You can see that this now updates over here. And what you'll notice is that if we actually look at what's being rendered, this terrain is filled entirely with these cubes. And what you can see here is that it only has to render these cubes in front of this object, and then you'll see that it doesn't render any of the cubes behind it. It does render a lot of the shadows in case they interfere. And then you'll see that even the terrain itself is actually culling out the blocks here that are behind here. And so we're drawing far less instances than we would without the various occlusion systems active. Now, Foliage Renderer has two occlusion systems. It has a traditional frustum culling. And so if I take this cube here and I move this guy, you'll see that that is also culling things out. It's actually easier to see this way. And that is using what's called high Z occlusion. So frustum culling is just keeping things in the camera view, and high Z will actually come in and figure out which objects can actually be seen based on what's rendered. So that can add a lot of performance when you're dealing with, hills, houses, things like that. And I don't think there's, I think there is another culling system that might do this on the store, but this one works pretty well to cut out extra stuff. So the way that works is you just turn this on. So we can see here we have shadow frustum culling on. If we turn this off, it's going to draw shadows all around the camera, right? So generally speaking, we want this on. There is a case where we don't want this on. So shadow frustum culling assumes that it knows the lighting information to figure out where the shadows can potentially project onto. So it takes a directional light and it will find this automatically from your scene. But if you're doing indoor scenes and you have lots of lights coming from different directions, etc., then you might actually turn this off because it'll only consider a single directional light for the shadow frustum culling. And that will increase the number of shadows you have to draw, but if you have that type of scene, that's just kind of how it works. And the high Z occlusion, again, we can turn this off, and you can see that all these blue squares here are appearing. And if I turn it on, then you can see it's culling all those out. And there is some additional setup for the SRPs, which is covered in the documentation, and I'm not going to go over those right now. But you can see how that culls out a lot of extra objects, and it's actually fairly cheap to perform. It's essentially a trick done with the depth buffer. Very, very smart little trick that someone came up with. I can't remember the person's name right now, but I really kind of love it because it's a very simple and elegant way to cull things. And then finally, you'll notice that these objects are a different color, and that is to basically test the LOD crossfade functionality. So for instance, you can see that this guy is crossfading between those two models. This is a 4-model setup. And if I move the camera around a little bit here, grab the camera, you can see the LOD crossfade working on these objects. You can see the culling, etc., culling them out when they don't need to be there. And so that's a testing scene essentially for me to make sure all this stuff is working. It also can be useful for you when setting up the high Z occlusion culling and the SRPs to make sure that everything is configured correctly with the scriptable render pipelines. So yeah, that's pretty cool and greatly helps performance. And let's go back to the train example scene. And I'm going to go ahead and dock this back. And get out of the trees here. This scene is also set up like that too. You could set up the little debugging views and have this scene show you, the same kind of occlusion. But let's talk about some more of these options. So once you create this, the foliage renderer is going to scan, find all your trains, and set them up with the correct components. And then once you've scanned and switched your shaders, if you have multiple scenes and you're adding this and you've converted some of the shaders, remember that if there are new prefabs in that scene that you weren't using in the other one, they may point to the old shaders. So you may have to do the scan again and hit fix on the shaders, and it will update them. And but let's talk about the settings here. So you have settings for basically trees and details. And by default, you can use the quality settings to set essentially your visible distance and things like that. So this will just read it off the terrain. Same thing for the shadows. It'll read it from the light of like what's the max distance that the cascaded shadow maps are going to work. So if we set these to manual, we can override that with new visibility distances. Same things for shadows. If we would like to draw the shadows out further than Unity allows, or closer. Now, it's only going to draw cascaded shadow maps for the distance that the cascade shadow map system works. So generally, I usually leave this on quality settings for the trees. But sometimes you want to override this for details because you realize that, hey, I can't really tell there's shadows from these tiny little stones off in the distance. It's not really adding that much, especially when I'm drawing out to 300 meters or something like that. So, I might draw these out to 300 meters, but only have the shadows happen to 80 or 40 or something like that. And that can help cut down the amount of rendering you need to do. In addition to that, you can actually specify the max LOD to be used for the shadow rendering. So often, when you're dealing with LODs, you have, a bunch of very high res stuff that is higher res than you need for the shadows. So you can just say, you know what, I just want to use LOD 2 for the shadows or lower. While we're on the topic of LODs, the system supports a max of 4 LODs. So if your models have more than 4 LODs, it won't use all 4. And it'll actually just use the last 4. So it's suggested that you reorganize your LODs appropriately. A lot of stuff that I've seen on the asset store has way too many LODs. There's some posts I've written about that. Generally, you don't need 5 or 6 LODs for things. For most stuff, it's 1 or 2 and an imposter at the end, right? It also supports LODs on detail objects, which Unity Train does not support. And so you can use those to help reduce cost and have higher res details up close if you want like really high detail grass or things like that. Finally, there's this little bounds expand option on here, and this is used to when it computes whether something is visible or not, it uses the bounding box of that object. This lets you expand it a little bit, and that can be useful if, for instance, you had lots of vertex deformation going on, say very high wind that's going to bend things over and push them around, or in the case of these rocks are not a big flat plane of rocks. They actually get conformed, so they get pushed up and down. And so in some cases you want to have a larger bounds for them. And so that can let you do that. You'll notice it smears off the edge because, well, it's the edge of the world. And it's still trying to conform that to the terrain. So essentially those settings are similar for trees and details. And then there's this final set of options here, which is when you're dealing with details on the terrain. The way that Unity stores them is basically like a texture saying how dense the details should be for each object. And when you are moving around, you're often not drawing the entire terrain's worth of details. So there's a streaming system that will only load in and compute the details that it needs, like one cell at a time as you move around. You can turn this off and basically just tell it to load all of this at load. And the only reasons that is there is because it does take a little bit of computation time to stream in new cells and combine them in the draw lists. And so if you set it to at load, it's going to use a lot more memory to load in the positions of all those objects because what it's doing is converting that into a list of positions as opposed to just a density number. So it's a lot more data. But you don't have to pay the streaming costs. In general, you can probably leave this alone. And the detail caching distance is essentially how far beyond the view distance of the details we should keep those details in memory. So if this is smaller, it's going to flush them out much quicker, and it'll do a lot more loading and unloading of details. If it's bigger, it's going to keep them in much longer. And so that's just a nice little option for basically memory management and whether you'd like to blow a lot of memory for a pretty what is now a pretty small gain. With the details set at 500 meters on my machine, it can take up to a millisecond to recompute that data structure, and that can be a spike when you're moving around, especially when you're drawing with incredibly large rendering distances. That's been pretty well optimized. When I started out, it was like 25 milliseconds, so there's probably a little more work I can do there to get it smaller. So in general, you probably want to run with streaming and just kind of leave these settings alone. But they are there if you would like to tweak them. So in the next section, what we have is we have overrides for the tree. And then we have overrides for the detail objects. And so you can select the tree, like this particular tree, and set up its settings to be completely different than these default settings. And you can do the same thing for like this rock here. And you can turn on this and change its settings. And that can be useful because it means you can take smaller detail objects and cull them quicker, especially when dealing with long distances, and then just leave the big bushes and things in the distance there. And then the final section lets you decide to supply different data to those materials. So if you turn on supply height maps, that will supply these height maps to the shaders that are used on the terrain, whether they support that or not. Obviously, the shaders have to be written to support that. Same for normal maps, and you can generate an albedo map. And then there's this thing called an extra texture config, and you can basically have as many of these as you want and set it up for So if I double click on this, it just says, here's the property name. So you have a property to say, is this data provided to the shader? And then you have a property for the center terrain, and then the terrains that border around it. And so in your shader, you can then do code to look up whatever that data is. And so this is an extensible system if you want to write custom shaders that do interesting stuff with data which is assigned per terrain. So for instance, you could put satellite data in here. You could put geolocation information or SDF fields or any kind of data you might want to use in your shader, and then your shader will be supplied with that for each terrain. And so in our renderer here, we see that currently we only have one terrain called terrain. If we had multiple terrains going right now, we'd see a list of them. And so then you can basically give them these textures and it will set them on the shaders for you so that as you move around and stream this world in and out and do whatever you're doing, those shaders get the right information about their texturing, this custom texture data. So that is really nice if you want to do funky things for shaders. Like a good application of this would be being able to paint how much wind is in a given area, or which direction the wind goes, so that all the trees move, in the right amounts and right places where you are in the world. You could paint down the hue of various vegetation and have it use that hue map to tweak the color of all the flowers or the plants or whatever. So by making the system really extensible, you can extend it with anything you want, as many things as you want, and basically provide custom data to all of these rendered objects in an efficient manner. So yeah, that's the basis of this system. I'm going to show. I should probably talk about what comes in the pack beyond the documentation, which everybody should read. There's some examples here. There's an example set of shaders. And so if we go into the shaders here, you'll see there's a lit shader. There's an example for the shader graph of how to add the indirect instancing to shaders. The shader patcher right now will not work on shader graphs or amplify shaders. Actually, it might work on amplify, but I haven't tried it. That may be added in the future. We may extend that more. But if you would like to add it in through shader graph, these are the nodes to do it. There is a shader include here, which contains the code. And there's also Better Shaders stackable. So if you're using Better Shaders to write your stuff, there's a stackable to add instancing support. That's actually included with Better Shaders. And then there's a stackable to add terrain aligned details here. And so if we were to look at one of those vegetation materials, let's actually find the rock one here. So the rock 04 here. You'll notice it has LODs, and actually, sorry, it does not have LODs. I just took LOD1 from a model. So this shader has some options for wind. This is the standard wind that most shaders use. There's a wind object you can place to add wind to your scene. That's also included in Microverse and in Better Lit Shader, along with a stackable for this. So what happened is Unity released some wind code ages ago and then pulled it, and every asset has pretty much used that wind code so that we're all standardized. We might interpret the data differently, but yeah, there's a wind stackable system in here. And then on the lit shader here, if we go further down, we have this align mesh to terrain shape. And if you turn that on, it will allow these rocks to read that data that's being provided by the foliage renderer and align it to the terrain. And then there's a tint mode here that you can set, which basically says, tint the rock towards the terrain. And this actually has several tint modes. It has like a basic tint mode. It also has height tint. And with height tint, you can set like a a fall off. So you'll see here that with like 0.3, it's blending these over zero point 0.3. So it's not blending them. Like if I set this to 0, you can see it's not doing any blending. 0.1, it's just blending the low sections up. So you can just tint the bottoms if you want. And again, this is mostly set up to demo this stuff and allow people to, including maybe myself one day, to write much more interesting shaders for terrain than is currently available. So that kind of shows off the shader options and the stackables and the included code you can use. The last thing I'm going to show you is something which is not shipping as part of Foliage Renderer. It is a separate asset. It is kind of the reason I wrote Foliage Renderer, and I'm not going to do a complete demo here, but you'll be able to see at least where I'm going with this stuff. And that is this mesh details module. And what this allows you to do is it allows you to use the detail rendering from Foliage Renderer on meshes in a scene, as opposed to using it only on Unity terrain. And it lets you do this both by painting meshes and using procedural techniques. So for instance, here on this root object, which contains several objects, I have a mesh point provider. I may change the name of that, but essentially what this does is it allows you to scatter objects on meshes using procedural techniques. And if you're familiar with Microverse, you'll recognize kind of this workflow. So I can choose various noises. I can filter by slope, angle, and height. And if I go and I change those options, like everything updates according to, and it'd probably be better on a sphere. So there was more than one slope value. So I can come in here and tweak the slope value, and everything updates accordingly. And so this is really nice because not so much in a kind of like I want to replace terrains fashion, but rather to place these things on objects in terrains and have the same kind of ability you have normally. It also has a painting interface, which will let you paint this stuff down. So if you want to paint, a house with some moss on it or whatever, you can do all of that. And this will be shipping as a separate module from the Foliage Renderer, but will require the Foliage Renderer. So the idea here is that a lot of people, what they really wanted me to write was just a faster terrain renderer, which I did, but I really only did it because I wanted to increase the capabilities and also to solve interesting problems like, hey, how do I scatter instances onto an object with arbitrary polygon density and keep a consistent level of density across the object. So that's kind of why I wrote the Foliage Renderer in the first place, even though people have been asking me to write this kind of stuff for a while. That's basically it, and hope this helps figure it all out. If not, read the facts, read the directions. Almost every question I get on Discord is already answered in one of the two. I suspect it will be not much different in this package. So, thanks. Bye.